Hi everybody, it's me again. And at our last class, at the end of the class, you remember we did this chapter 11, problem number 18, which is our build a model, and we had we came up with the net present value of $3,463. We went through this calculation of coming up with the sales revenue and the net operating profit after taxes, coming up with the net present value of $3,463 and 21.9% for the internal rate of return. And then we ended the class talking about deviations from the base. Say this is the sales. The sales price is $24 per unit. And so one of the things we want to do is there's some deviations from that $24. And so we say what happens if it goes down 20%, and so that would make the price become $19.20. And then in another instance we would say, okay, what happens, we want to know what the net present value will be if that price goes down just 10%. And of course if it's the same, zero variation. But what happens if the price goes up by 10%? And what would the net present value be if the price went up 120%? And so in order to figure that out, we're going to put the net present value for $24 right here. And what we'd like to know is what it would be at those different prices. So to find that out, we are going to click Data and play the what if analysis, get the data table, and go up here and so it's if we put that data table and we put $28 in there, and then we click, and voila, we get what it says is if the sales price went down 20%, the net present value would go from $3,463 to a minus $5,893. If it goes down just 10%, it's a minus $1,212. If it goes up 10%, the net present value goes up to $8,141. And if it goes up 20%, it goes up $12,820. So that shows that variation in net present value if we have those deviations from the base case. So now let's take deviations from the variable cost, and we see the variable cost was $17.50. Now if it goes down 20%, and I multiply that by 0.8, get 14. If it goes down 10%, it's $15.75. And of course, if it's zero, it's $17.50. And then if it goes up by 10%, we're going to multiply that by 1.1, and that's $19.25. I just kind of like to check my numbers all the time. That's 1.2 goes up to $21. So now what we want to do is find out what would be the variation in net present values if the variable costs went down by 10%, went down by 20%, went up by 10%, and went up by 20%. What would the variation be? How would those deviations impact the net present value? And to find that out, we go to our data table and we go up here and we come down, click it in there, and we see what those variations are. Basically, if the variable cost went down 20%, the net present value would go up to $10,401. If it went down 10%, it would go up to $6,932. If the variable cost went up by 10%, the net present value would go down to a minus $6. And if it went down 20%, it would go down to $3,465. So now let's find out what kind of an impact it would have on net present value if we change the number of units that we sell. And of course, this is easy. If it's 1,000, so if it's 20% below 1,000, it's 8. And I guess I really probably should, to be on the safe side, go like this and multiply it by 0.8. I just want to make sure that this will connect right. If it goes down 10%, it's 900 units, and now if it's 0, it's 1,000. If it goes up by 10%, it's 1,100, and if it goes up by 20%, it's multiplied by 1,200, 1.2. So now we want to get our net present value in there. Whoop, what did I do? I want to pull it. I want to copy that down there. So now we've got these variations, and let's see what kind of an impact variations in these will have on the net present value. So this time I'm going up to the number of units that are sold. And you can see if the number of units drops 20%, the net present value goes down to $1,045. And if it's at 10%, it's $2,254. And if it goes up 20%, then the net present value goes up to $5,882. So now we got those there, and those prices, or those net present values of those variations are there. So let's see if we can get that graph here. I'm going to go over here, and I'm going to go to the line one here, and I'm going to click on this one so that we get, oh, that isn't what I want. Let me just see if I can move that out of here and get, I've got to go down here. Now let me go up and see insert. Okay, here we go. So let me just take this and pull this over here. And what we want to do is I want to click on this one now so that we can put in a chart, and I'm going to call it a sensitivity, S-E-N-S-I-T-I-V-I-T-Y. A-N-A-L-Y-S-I-S, and that prints out here, and I want to have this one be net present value, and there you see it at the side. So now I want one more thing. I'm going to take this select data, go over here. I want to select this range right here of variable percentages. And you can see it's over here. So you can see the percentages. When it's a minus 20, this is what will happen. Positive 20 and so forth are there. So what you see is, yeah, when the variable cost is red, when the variable cost is a minus 20%, it really enhances the net present value. On the other hand, if the sales is positive by 20%, look what happens to the net present value. It goes above $10,000. So anyway, this gives us a pretty good idea of how these variations take place. And this is a sensitivity analysis that shows the impact of changes in sales and variable costs and the number of units sold on net present value. I hope I'll see you in class, and if you have any questions, we can talk about it. Thank you.